Yeah, except for, copying off your neighbor. But okay, yeah.
Number 14.
Number 14 on the worksheet. Okay. What else? Yeah. 27. What else? Yeah. 23. What else? Yeah. 15. Anything else? Good? Perfect. If you come up with one while we're doing it, happy to do it. Okay, so I have 3x squared plus 19x minus 14 is equal to 0. Factor each first, then solve for x. Okay, so you know it's solving because there's an equal sign. So we want to factor it. So our magic number is 3 times 14, which is 42. And we want it to be a negative 42. Why is that? Yeah, because negative 14. So that means that we have alternating signs. We want to figure out which factors of 42 would add up to be positive 19, having one positive, one negative. So I know 1 and 42 works. I know I have 2 and 21. I think I could stop there. What do you think? Because positive 21 minus 2 would work here, right? So minus 2 and positive 21. So let's see. I can just plug it in. Order doesn't really matter as long as I keep the sign. So 21x minus 2x minus 14. Did I do that right? If I add those back together, I get to there, right? And so this combination will work. So what do I have in common between those two terms right there? I have a 3x, exactly. And that leaves me x plus 7. Cool. If this is a negative, the majority of the time you come across these problems means you'll factor a negative out. Now I'm going to factor a negative 2. And then if I factor negative 2 out of negative 2x, I get positive x. If I factor a negative 2 out of negative 14, I get positive 7. Does that make sense for me to do that? Negative 2 times x is negative 2x, negative 2 times positive 7, negative 14. So now I have these two terms that are the same, so x plus 7, and then what do I have left? I have 3x minus 2 left. And it said to solve, so this is now factored, but it says to solve, so we need to set each of those binomials equal to 0. So I have x plus 7 equals 0, so x equals negative 7, that's one of our answers. And then I have 3x minus 2 equals 0. So 3x equals 2, x equals 2/3. If I go back and plug those back into the problem, they both will work. So my answers are negative 7 and also 2/3. Is that okay? All right. 27. We have, let's see, 1/2 x plus 4y is equal to 0. 1/4 x plus 3y equals negative 1. Solve each system. Okay. Honestly, I don't like how they're set up because I have a fraction in there. So, have you ever heard the term clear the denominator? Okay. What that means is I want to just modify each. So this whole thing I'm going to multiply by 2. So 2 times half is 1, or 1x is the same thing as x. 2 times 4 is 8y. And 2 times 0 is 0. So I've cleared the denominator on the first one. What should I multiply all three terms by on the second equation? 4. Okay, because I have a denominator of 4. 4 times 1/4 is 1x, which is just x. 4 times 3 is 12. I get the y in there. And then 4 times negative 1. So now I have cleared the denominator of both equations. Agree? If I add the two equations together as they sit, I'm going to get 2x plus 20y equals negative 4. So none of the x's or y's fell out. I have to, now it's set up, I pick one of the equations and multiply everything by negative 1. So if I multiply that, that means I get a, I'm just going to rewrite this right underneath here. Negative x minus 8y equals 0. And now if I combine both of those together by adding, My x's cancel out. 12y and minus 8y is 4y. And then negative 4 and 0 combined is negative 4. So I get that is one of my answers. Am I done? No, what do I have to solve for still? X. I can plug it into any of my equations that I have, even the modified ones, for as long as I still have x and y. So what I mean by that is I can take this value, which is a y value, I can plug it in here, here, I can plug it in here, I can plug it in here, I can even plug it in there. So you just have to pick one that still has both letters in it to plug it in. So I don't know, I'll pick this one. Is that all right? So I get 8, or x plus 8. There was a y there. What's going to go there? Negative 1. So that gives me multiply, add, and that's my solution. If I had graphed these, they would intersect at the point 8 comma negative 1. You okay so far? Right. 23, and I can go back if anyone needs me to go back. Let's see, negative 4x plus 7y is equal to negative 13. 2x plus 4y is equal to 14. Okay. Substitution probably doesn't look like a good idea. I think if I add, or if I multiplied the whole second equation by 2, my x's would reduce or cancel out. Agree? Okay, so I'm going to take this, multiply this whole thing by 2. So this top one comes down, it's just this. Nothing changes on this one right now. And on this one, I'm going to get 4x plus 8y is equal to 28. Cancel those, right? It gives me 15y equals 15, right? Negative 13 added 28 is 15. Divide each side by 15, so I get y equals 1. I can plug that back in, this back into anywhere that I have both x and y. So I can plug it in here, and here, here, or here. Okay? Don't plug it back in here. You'll get, oh, it's infinite solutions. No. You need it both x and y. So I'll pick the top equation to plug it into. I have negative 4x plus 7. There was a y there. What's going to go there now? 1. So I get negative 4x plus 7 equals negative 13. I'm going to subtract 7, so that gives me negative 20. I'm going to divide by negative 4, so that gives me positive 5. So 5 comma 1 is my solution to that problem. Again, if I were to graph it, it would cross at 5 comma 1, those two lines. Can I move on still? All right, number 15. 9x squared minus 4 is equal to 0. Factor first, then solve for x. What does this problem appear to be? What's the specialty of it? Yeah?
They're perfect squares.
They are perfect squares separated by a subtraction sign, so it's known as what? Two squares. Okay? So difference of two squares would mean the square root of that is 3x, square root of that is 2. I get 3x and 2. Make them conjugates of each other, meaning they're the exact same binomial with one sign different. Okay? I want to solve it. It's equal to 0, so let's solve it. So let's set each of these equal to 0. Subtract 2. Divide by 3. Add 2. Divide by 3. So I get negative 2/3 and positive 2/3.
I got the exact same answer, but I did it a different way. I added 4 to each side and then divided by 9 and then did the square root.
I was going to go that way as well. The only thing is it just said factor first.
Oh.
That's what. But you know what? Honestly, when I grade a paper, I look for the answers first and then go backwards. So if you had the answer wrong, then I go back and then I start realizing the direction. So if you did it your way and your answer's correct, you're probably going to knock it out of the park. Okay? And you're absolutely right saying, I want to do it this way. I honestly would have probably solved it that way as well. So So what she's saying is she would have added 4 divided by 9, then taken the square root, realizing you have plus minus for an answer. Okay, same exact answers. Again, yes, there's certain ones like that one especially. I think that would have been a great one to do your way. I was just trying to follow the directions for once in my life. Okay, let's see. That's it. Was there any other questions? Yeah. 2. Number 2. Let's see. 9x to the third, y to the fourth, plus 12x to the fourth, y to the third. They want us to find the greatest common factor. So that means that we would have a number, a letter, or a combination of both that we could factor out. So let's look at the numbers first. So I have, what's the largest number that I could factor out of both 9 and 12? What goes into both of those evenly? 3. So 3 would factor out, okay? I have, this is the same thing as saying xxx, and this is xx, xx. So how many x's do each of them have in common? 3, so that's x to the third. And then y, and y. How many y's can I factor out of each? 3, so that's y to the third. Okay, so if I factor 3 out of 9, I'm left with 3. If I factor x to the third out of x to the third, everything's factored out. If I factor y to the third out of y to the fourth, I have a single y left, so I have a y there. Plus sign comes along for the ride. If I factor a 3 out of 12, I have a 4 left. If I factor an x to the third out of x to the fourth, I'm left with an x. And then y to the thirds both come out. So that should be as reduced as you could get it by factoring the greatest common factor. Okay. We good? All right. So a few things just to think about. I got a few emails from parents and students that said, you know, I might be in the wrong class. That happens. So if that's the case, let's make sure we get you to an appropriate location as soon as possible. Because there's one thing I definitely know, and please understand this. I am good at math because I worked my tail off for a long time to get good at math. When I was in high school, I wasn't as good at math as I would have liked to have been. And I remember when I went from high school to college, they're like, oh, you did really well. We didn't have AP Calc. Our schools had just started getting it in our school, but it wasn't one. So I was at Arizona State. They put me in Calc 3, even though I took Calc in high school, but they put me in Calc 3. And it was just like, oh my gosh, it was like complete Greek. And it's not because I was dumb. It was because they put me too far over. And so then I actually went back and took Calc 1, 2, and 3 in college. And then my understanding was really good. I actually took another class with Calc 1, and everyone thought I was joking why I would take it, but I took trigonometry, which was just, it's such a beautiful math class. Oh my gosh, I love it. Sine, cosine, tangent, and all the different fun things it does with all the graphs. It's wonderful. So there's a plug for trigonometry for y'all. But the one thing when I realized sitting there in that Calc 3 class, and I sat there for the whole semester going, oh. And it really frustrated me with math. So I wanted to make sure the following semester I moved back into the appropriate location, and from there on, I felt really good about myself and then when 2 semesters later, I took the Calc 3 again, got an A in it. And so, I dropped it at the wrong time. I dropped it so it was the withdrawal F. So I have an F on my transcript because I withdrew from a class that I shouldn't have been in the first place, but I took too long, and then I didn't even give me any money back. So it was like horrible. So I just want you to know that if you feel that you might be in the wrong spot, let's make sure we get you to the right location. Because again, math is a beautiful thing until you're in a place where it's like it looks like ants crawling on the page because it's just so far out there. Good? Clear your desks.